Hello everyone, I am Sabariswaran. I am currently pursuing my bachelor's degree in the Department of Artificial Intelligence and Data Science at KJSL Institute of Technology. In this session, I am going to teach you about machine learning. The term machine learning was founded by author Sam Whale in 1959. According to the author Sam Whale, machine learning is nothing but the ability of computers to learn and make predictions without programming them. A machine learning is a subset of artificial intelligence. Computer can learn from their past data, make decisions, and predict the future. There is no need of human intervention in machine learning. The machine learning is used in e-commerce sites, Netflix, etc. Machine learning is a subset of artificial intelligence. Neural networks are the subset of machine learning, whereas deep learning is the subset of neural networks. Machine learning involves building algorithms. Depending on the type of data used, there are different types of algorithms. The foremost process in machine learning is gathering data. They can be called as training data. Training teaches the algorithm to learn by using tons of data. After the training is given, a new input data is fed to algorithm to make their predictions. The algorithm is trained many times until it reaches the desired output. Next comes the types of machine learning. The types of machine learning includes supervised, unsupervised, and reinforcement learning. Coming to the supervised learning, the algorithm here is trained using labeled dataset to make their accurate predictions. For example, when we train an algorithm with pictures of apples, after the training, the algorithm is able to give accurate predictions of apples. That is, the image of apple is currently identified. Supervised learning includes regression and classification models. They are trained using labeled datasets. The difference between regression and classification is that regression is used to predict continuous values like age, salary, etc., whereas the classification is used to predict discrete values such as true or false, spam or not spam, 0 or 1, etc. Here is the diagram for the classification and regression. The major difference between the regression and classification algorithms is given below. In regression, the output variable must be of continuous nature. In classification, the output variable must be a discrete value. Regression algorithms uses continuous data. Classification algorithms uses discrete data. In regression, we try to find the best fit line which can predict the output more accurately. In classification, we try to find the decision boundary which can divide the datasets into two different classes. The regression algorithm can be further divided into linear and nonlinear regression. The classification algorithms can be divided into binary classifier and multi-class classifier. Unsupervised learning is training the algorithm using unlabeled data. For example, the algorithm is trained with different pictures of many fruits. In this scenario, the algorithm finds the similarities and patterns among them and group the fruits accordingly. Reinforcement learning. It is a feedback based learning technique where the agent interacts with the environment and learns to act within that. For each good action, the agent gets a reward, and every bad action, the agent gets a penalty. Here, there is no labeled data. The agent only learns with its experience. Here is the diagrammatic representation of the reinforcement learning. The tools used for data development and deployment are given here. The most commonly used machine learning algorithms are linear regression, logistic regression, LSTM, decision tree, random forest, etc. The common applications of machine learning includes virtual assistants, face recognition, fraud detections, etc. The steps in training a ML model includes data processing, training a model, and evaluating their performance. In machine learning, there are three types of fitting like underfitting, overfitting, and appropriate fitting. Overfitting is the scenario when model performs very well in the training but results in poor performance in their testing. When a model is not trained properly and unable to perform in test, then it is known as underfitting. To evaluate the model in machine learning, we use the performance metrics. Performance metrics can be used for both classification and regression. Metrics for the classification includes accuracy, precision, recall, F1 score, and AUC. Regression metrics includes mean square error, root mean squared error, mean absolute error, etc. The confusion matrix is a table that is used to define the performance of the classification algorithm. Let us see a small hands-on for building a classification model using decision tree algorithm.
Now we are going to build a decision tree model using Python and some libraries. Libraries are set of programs already written to make the calculations simpler. Our model will predict whether the player can go for playing based on various factors like weather conditions, temperatures, etc. For that, importing the necessary libraries is must. First, Pandas. This is a powerful package that has some functions for data analysis and manipulation. NumPy. It is used for scientific calculations and array calculations in Python. sklearn. This is a free machine learning library that contains many functions and methods that are necessary to build a machine learning model. Label encoder. Label encoder is used to convert the categorical variables into numerical variables. First, we are importing the dataset named tennis.csv. For that, click on these files and click this upload. Select the file. Once the file is loaded into the Colab, copy their path and paste it. Let us display the values before the label encoding. The data seems to be categorical, so we need to convert it into numerical because the decision tree algorithm takes the input only as numbers, and that's why we are going with a label encoder function to change the values into numerical. Let us print the values after the encoding. Here you can see that in Outlook column, overcast is encoded to 0, rainy is encoded to 1, and sunny is encoded to 2. This is done for all the values. Now let us declare two variables named as independent and dependent. We are selecting the target variable dependent whether we can play or not, and the features to predict the target variables in the variable dependent. We are calling the decision tree classifier from the tree and assigning it into the variable named model. Then we are fitting the model to our independent and dependent variables. At last, we are predicting the trained model and printing their values after checking with the original value of the whether a game can played or not. Thank you for this opportunity. Hope this session finds useful and informative. Thank you.
Hello